All right, folks. Sorry that I'm not here today. I will see you on Monday. Make sure you watch till the end of this video because, or at least scroll to the end of this video because I'm going to give you specific instructions on how I want you to work some of these problems at the end. And I'm going to skip through some of the slides on here because they're just kind of peripheral information that we don't really need to focus on and try to get to the essentials. So we're talking about rational functions here. We've talked about these a little bit before. Remember, a rational function is a function where you have one polynomial over another polynomial. So both P and Q are polynomials in a rational function. So if at any point you need to pause and read through something, do it. But I'm going to go quickly so I can get this all in my allotted time. So rational functions have asymptotes. You've seen the function 1 over x before. We had that as one of our parent functions. It was a function that looked like this, and it never crossed the axes. So we would say it has a vertical asymptote at x equals 0 and has a horizontal asymptote at y equals 0. Most rational functions are going to have both vertical and horizontal asymptotes. Not all of them will, but that's a pretty common occurrence when it comes to rational functions. So the next couple slides give you some details about how you can describe behavior of asymptotes, but our main objective in this course is going to be just to identify what the asymptotes actually are. So again, if you want to pause on this slide and look through any of it, go for it, but we're going to move on. We're also not going to worry about transformations of 1 over x. So we're going to move on to asymptotes. So this box summarizes how to find asymptotes, because we said there's both vertical, you can see here, vertical asymptotes, and there's also horizontal. Verticals occur when there is a value that causes the denominator to be 0. And so we can get those by factoring and determine what those values are. Horizontal asymptotes are a little more complicated. There's a set of criteria you see here. If you notice, m and n are used a lot. M and n are the exponents, or the degrees of the polynomial functions. So when the n is less than the m, the top is less than the bottom, the asymptote is always y equals 0. So when the degree of the top is less than the degree of the bottom, asymptote's always y equals 0. When the degrees are equal, then it is the ratio of the leading coefficients. These are lead coefficients. Okay? And so that's how you get it. And you just do the top leading coefficient over the bottom leading coefficient. When the top is greater than the bottom, there is no horizontal asymptote. There's what we're going to call an oblique or a slant asymptote. We will get into those more on Monday, not today. So if we want to find the asymptotes of a function, what we need to do is factor it. So we need to factor the numerator. If you want to pause the video and factor it on your own, that's of course recommended. But if you want to just watch me go through it, that's fine too. So let's see. I think we're going to have -1 and +1 here, and then we're going to have let's see, +2 here and -1 here. So if you'll notice, the vertical asymptotes, this function, will occur when the denominator equals 0. So this factor right here would come to the solution of x equals 1/2. That's a vertical asymptote. And this would be x equals -2, another vertical asymptote. Horizontal asymptotes are going to occur, in this case, notice the exponents, again, the exponents are the same. So if you revert back to this listing up here, that means that we use the ratio to determine the horizontal asymptotes. Y equals 3 over 2. It's just as simple as 3 over 2. So that's how you find the horizontal and vertical asymptotes. The next thing we're going to do is graph these functions. And there's a set of instructions here that you can see that are kind of tips to how to graph. Read through those, but essentially we're going to factor first, find intercepts, we're going to find asymptotes, vertical and horizontal, and then we're going to sketch the graph. Now, what the book would suggest is that you like test points to fill in. What I'm going to suggest is that you use your graphing calculator to help you get an idea of the shape. I will not require you to graph these by hand. You can always use your graphing calculator to help you get the shape. But I may require you to show work for how you found different things. So first function we've got here, we have this function. We're going to factor it first. So again, I would recommend you pause it and go through and try to factor this. And then for your assignment today, I'm going to want you to find all of these things. So the book is going to give you different instructions. The book is going to tell you just to find a couple things. For each of the, I think, 5 problems I assign you, I want you to find all the things listed here. I'll talk through how to find those as we go through this exam. So we're going to put a +4 here. We're going to put a -1 here. We're going to put a +2 here and a -1 here. So there's your factorization of the function. So we can get vertical asymptotes from what we see right here. We can do x equals 1 and x equals -2. Now, the domain and the vertical asymptotes are very closely tied together. The domain of this function is going to be every value except those 2 asymptotes. So we're going to say not equal to 1 and -2, and that is perfectly acceptable for how you write the domain. Horizontal asymptote comes from the leading coefficients. So in this case, the exponents are 2 and 2. The exponents are the same. So we do the ratio. We do y equals 2/1, and 2/1 is just 2. Okay, x and y intercepts. X-intercepts occur when y equals 0. Okay, so that's essentially meaning we're going to set the function equal to 0 because we know that r of x is the same thing as y. So if you set the function equal to 0, the first step you have to do to solve for the y-intercept is to, rewind. X-intercept occurs when y equals 0. So that's what we're finding right now, is the x-intercept. I've set 0 in for y. You need to cross-multiply everything in the denominator here over to the left-hand side. But when you do that, all this stuff times 0 is just 0. So essentially, when you want to find x-intercepts, you want to find when the numerator is equal to 0. So when you do that, we're going to get an x-intercept of 1/2. And actually, I am going to write that in point form. I'm going to write that as 1/2, 0. And then we're going to have another one at -4, 0. All right, y-intercept. Y-intercept occurs when x equals 0. I would recommend going back to the original function here. If I plug in a 0, a 0, a 0, a 0, all those things become 0. And so what am I left with? I'm left with -4 over -2. So my y-intercept is just 0, 2. In order to find minimums and maximums, you would have to graph it on your calculator to give yourself a picture of what that looks like. And also the range. So I'm going to do that real quick, and we'll be back. All right, hopefully you paused here and took a minute to graph your function on your calculator. When you do the graphing, what you need to do is draw in your asymptotes. So I have an asymptote. We always dot them at x equals 1. And then I have an asymptote at x equals -2. And then I'm going to have another horizontal asymptote at y equals 2. So I'm dotting all my asymptotes here to plot them. And then I'm going to look at my graph on my calculator. I'm going to see that over here, I've got this piece. And that confirms an x-intercept of -4, which we figured out over here. In the middle, I'm going to have this piece doing something like that. That is going to confirm an x-intercept of 1/2 and a y-intercept of, apparently the y-intercept of 2, so I was a little off base here. The y-intercept should be about right there. And then our third branch is over here. So there is no minimum or maximum on this function because it never reaches a high or low point. It is always decreasing the whole time. The range, we might be tempted to say that the range is y is not equal to 2. However, if you'll notice right here, our function crosses the asymptote. So our range is actually all real numbers and not y equals -2. So this is the stuff that I'm going to want you to do on each of your homework questions. And I want you to sketch a graph. That is your goal for today. There's another example here. If you would like to, you can pause the video. I'm going to work all this out, and then I will restart the video, and the work is just going to appear right in front of you. So you can check your answers if you'd like to, given that. So be right back. All right, poof. There is the working for example 5 here. Notice the denominator is never equal to 0. So your domain is all real numbers, and there are no vertical asymptotes. That does happen occasionally with these functions. You do have a horizontal asymptote because of the relationship with the coefficients, and you have two x-intercepts at 2 and -2. You have a y-intercept at -2, and the minimum is also the exact same value as the y-intercept. There are no maximums on this function. It's hard to tell. I'm trying to get my graph to kind of keep going over here, but I kind of hung downwards a little bit there. And then your range. Your function never goes above the horizontal asymptote of y equals half. So it is going to always be less than y equals 1/2. But it's always going to be greater than or equal to -2 because it never drops below the minimum. So that's how you would be able to analyze that function and figure out some of those things. That is it for today. I know that's actually a lot of things to do at one time because I'm asking you to find, 6 or 7 things here. But that is your task. There are 5 problems. Don't sit there and watch cat videos on YouTube. Do your assignment. That's your assignment. Of course, you probably know that already. 5 problems. Graph it and find the information that I requested. You guys have a great weekend. I'll see you Monday, and we'll finish up the rest of this section then. Thanks.